Welcome to Mechanical Engineering Thermodynamics. In Mechanical Engineering Thermodynamics, what we will do is begin by looking at the definition of thermodynamics. And what we're assuming is that this would be your second course in a thermodynamics curriculum. So in the first thermodynamics course, you would have covered things like the first law, second law, perhaps the Rankine cycle, properties of materials. In this course, what we'll be doing is we'll be going a little further with the concepts, and we'll be applying the things that you covered in a first introductory course on thermodynamics to a lot of systems that are important to mechanical engineers. And consequently, a first course in thermodynamics has a tendency to be a little bit on the abstract side. This course has a tendency to be more on the applied side. So personally, for myself, I found this course very rewarding because we're looking at systems that we can relate to. But what I want to do at the beginning here is step back and take a look at the definition of thermodynamics itself. So thermodynamics, there are a number of different definitions that you'll find. Sometimes people will say thermodynamics is the science of energy management, but essentially what we're doing is we're looking at the transformation of energy from one form to another. Remember, energy cannot be created nor destroyed. It is merely transferred from one form to another. And it could be internal energy, it could be potential energy, it could be kinetic energy. And through those transformations, we also have energy in the form of either work or in heat. And those are the things that thermodynamics looks at, is the relationship of energy transforming from one form to another. So to put a definition, thermodynamics is the study of energy transformations and it's a study of energy transformations and the relationships among the physical properties of substances which are affected by those transformations. Now, quite often those substances in any kind of thermodynamic cycle that a mechanical engineer would be interested in are as referred to as the working fluid. So that provides us with the definition of thermodynamics. Now, in this course, what we will be doing is we will be applying thermodynamics, as I mentioned, to a wide variety of systems that mechanical engineers may be dealing with. So what you could look at in terms of the areas that mechanical engineer or thermodynamics would be applied, it can be applied to very diverse areas. And these can consist of a number of different things. One is power production. Power production is an area that is very important in modern day society. We have power production, which is generating the electricity by which I'm recording this lecture. We have, and that's referred to as being a stationary power production system, because usually I'm recording this from China. And so the power here is probably, my guess would be coming from coal, a coal burning power plant. If I was recording this from northern Germany or Denmark, for example, then perhaps it would be coming from wind energy. So those are referred to as being stationary power production units. And then we also have mobile power producing units, and these are units that, just like it sounds, are mobile. So it could be the engine in a motorbike, the engine on an airplane, it could be the engine in a car. Those are all power producing units that are mobile because they're moving around. So that is one area that you can apply thermodynamics, both stationary. So those are power producing units that are tied to the ground essentially and not moving, and mobile power producing units. A second area that you can apply the concepts of thermodynamics to, and we will look at in this course, is what is referred to as refrigeration and air conditioning processes. So refrigeration is one process that we will be considering in the course, as well as air conditioning processes. Quite often referred to as being heating, ventilation, and air conditioning, or HVAC. Another area that we can apply thermodynamics to are fluid expanders. And those are quite often referred to as being turbines and compressors. And actually a pump is a form of a compressor, but it's for a liquid. Traditionally, when we talk about compressors, we're talking about a gas for the fluid that would be going through. Other areas: jet engines and rockets. And so we will be looking at the cycle of a jet engine later on in the course, and that is referred to as being the Brayton cycle. We won't be looking at rocket propulsion in this class or in this course. However, rocket propulsion, you would use all the laws of thermodynamics and then chemical reactions for whatever reaction is taking place in the rocket. Other areas where you could apply thermodynamics: chemical processing in oil refineries. This is an important area for people within Alberta because a lot of our energy and a lot of our industry is related to the oil and gas sector. And consequently, the processing of any of the oil, be it conventional oil, be it heavy oil, or bitumen from the oil sands, needs to undergo forms of upgrading and refinement. And you would be applying the rules of thermodynamics there. Once you have that, let's say you make gasoline, what we often do with gasoline is we burn it. And that is really referred to as being combustion. Combustion is the process. So we could be looking as well at combustion of hydrocarbon fuel. And that is something that we will also be looking at in this class. Later on, we'll be looking at areas, it's referred to as the heat of formation within a chemical reaction. And from there, that's how you can figure out the amount of energy being released through combustion. And there you're converting chemical bonds into thermal energy. And so we'll be looking at that. And then if we go into other forms of energy, so more on the renewable side, we could be looking at solar energy units. Now, when I'm referring to solar energy here, I'm really referring to solar thermal. However, there are certain systems that use solar energy that can produce electrical or mechanical work, which you would then put into a generator and convert electricity. But when I'm talking about solar, I'm not talking solar photovoltaic. I would be talking about solar thermal systems that could either generate thermal energy for household use or industrial use, or it could also generate power, so mechanical work, as well as thermal energy. So that's what we're referring to there when we talk about solar energy units. Another area, geothermal energy utilization. When you're talking geothermal, essentially what you have is a system whereby you're bringing heat up from deep underground, quite often in geologic formations where you may have mountains, such as Nevada. That's one location where they have quite a bit of geothermal energy. And Iceland as well, that would be another example. And so you're bringing up heated fluid and you're putting that into what we would call a heat engine, or it could be a Rankine cycle, anything like that. And you're producing work through that process. So that would be geothermal energy utilization. And wind energy. Wind energy is another area. We won't necessarily be looking at it in this course. However, the laws of thermodynamics would apply to wind energy. You'd also have fluid mechanics involved, and aerodynamics. And finally, tidal power is another system where you may be applying the laws of thermodynamics. So you can see with that, there are many, many different areas that we can be applying thermodynamics, and in particular areas where mechanical engineers would be involved. And we will be touching on a number of those areas throughout this course.